Hello everyone, welcome back. In the previous lesson, we learned how to analyze data using numpys and statistical functions. And today we are going to learn how to change the structure of data without changing the values. And this is the most important because different machine learning algorithms expect data in the different shapes. We also learn how to generate random data, which is useful for testing our programs and creating a sample data set. And here is a small example for you. Suppose someone uses this marks list as a single list, but our program needs the data in the rows and column. Should we retype everything again? No, right? That's exactly benefits of this numpys. Numpys lets us change the structure of the array without changing the actual data by using these reshape, transport, seed, flatten, and random numbers. Let us go one by one in the brief way. Okay. Let us start with reshape. Here we are imported numpy as np. It will create a single dimensional array. Shift enter. Now we will get the here the current here the currently this is the one dimensional array. Now let us convert it into a table using the reshape. What reshape? Here let us see the output here first. Yeah, here reshape 2 comma 3. It means 2 rows and 3 columns. Notice that the values didn't change here, only the argument change. Here is the another example for you. Reshape 3 comma 2. What is 3 here? Rows. And what is 2 here? Columns. Shift plus enter. Here the same data can be arranged in the different ways. As long as the total number of elements stays the same, reshaping is possible. Here is an important rule for you. If our array has is 6 values, we cannot shape it into 4 rows and 2 columns. Why? Because we has only 6 values. 4 comma 2 means 4 rows and 2 columns means 4 into 2. But our array has only 6 values here. 1, 2, 3, 4, 5, 6. 2 comma 3 it means 6. 3 comma 2. 3 into 2 6. But 4 comma 2 means it goes to 8. But our array has only 6 values. The total number of elements must always remain the same. Okay, now let us move to the flatten. What flatten? Now let's do in the opposite way. Suppose we have a table and we want to convert it into single list. Okay, now we want to convert it into a single list. On that time we will use the flatten. It converts a multiple dimensional array into one dimensional array. What? It convert multiple dimensional array into single dimensional array. Let us see the output here. Yeah, we got the single dimensional array. Now let us move to the next one, transpose. Sometimes we want rows to becomes columns and columns to become rows, and this is called transpose. Okay, now we'll run this program. Yeah, we got the output here. Look carefully here. Before, 2 rows and 3 columns. After using the transpose, we got 3 columns, 3 rows and 2 columns. Okay, look carefully here again. Before, 2 rows and 3 columns, and after using the transpose, 3 rows and 2 columns. Okay, now let us move to the next one, random numbers. What? Random numbers. Sorry, I have forgotten one thing here. Now you might ask, why is transpose useful for? In the machine learning and the data analysis, some algorithms requires data in the different variations. On that time, we will use the we will use the transport. Instead of rewriting the data set, we will simply transpose it. Okay. Now let us move to the next one, random numbers. So far, we entered all values manually, but sometimes we just need sample data to test our code. Numpy can generate random numbers automatically. Okay, here these are the random numbers. Here random dot radint 1 comma 100 comma 5. It means starts from 1, end from 100, and generate 5 random numbers. Okay, what here? Starts from 1 and end from 100 and 5 random numbers. It will use the numbers between 1 and 100 only with 5 random numbers. Okay, now let us move to the next one, random decimal numbers. Okay, random decimal numbers. Here rad it will, here rad it, see it is a rand it will generates the random decimal numbers between 0 and 1. What? A rand generates the decimal numbers between 0 and 1, only 0 and 1. Let us see the output here. Yeah, we got the output from 0 and 1 only. Okay, now let us see the most important one, seed. What? Seed. Sometimes we want the same random numbers every time, right? That's where seed is useful here. Using the same seed gives the same sequence of random numbers every time, and this helps when reproducing experiments. Now let us see the output here. Yeah, we got the output. Okay, now let us see the mini project which I made for you, and this is a small mini project, and don't worry about it. In the upcoming videos we will do the big projects which is useful to your resumes. Okay, here I made a small mini project for you. Here we generate a here we generate a 10 random roll numbers automatically. Okay, this is much faster than typing them manually. That's why I created it, just for sample purpose. Okay, and here are the small mistakes for you. Here are the small common beginner mistakes for you. Here the mistake one is trying to reshape into a impossible size. It means I already explained you in the above. Like, we only have 6 values. We only suppose we see, wait a second. Suppose we have 6 values. 2 comma 2 comma 3. It is okay because 2 rows and 3 columns. 2 into 3 6. But here 4 comma 2. It means 4 rows and 2 columns. It means 8. It is not possible, right? Mistake 2, forgetting that random numbers change every execution. On that time we will use seed. When you need the consistent results, on that time you will use the seed. Okay, I hope you understand. In the next lesson we will combine everything you learned in the small mini project. Okay, that feels like a real data analysis task. Okay, after that we will move to the pandas, where students will start working with the real CSV files. Please support me and do subscribe. Thank you.